Welcome to our course on machine learning. Before we get started, let's look ahead to see what's coming up in this course. This course approaches machine learning from first principles. We want you to get an intuitive feel for the different problems and algorithms without getting bogged down by a lot of abstruse mathematics. If machine learning is a car, we want you to be able to drive the car first, even if you don't know all the nitty-gritty details of how the engine is actually built. To understand the power of machine learning, we'll start off with a familiar real-world problem, detecting spam in your inboxes. We'll see how machine learning solutions to this problem can be far superior to rule-based techniques. We'll also introduce some of the terminology that you will come across again and again, which might sound intimidating at first, but which will make sense once you relate them to a real-world problem. At the end of this first section, you should be able to recognize the situations where it's appropriate to use a machine learning solution. Next, we'll introduce the different categories of machine learning problems. Most real-world problems fall into one of these categories. At the end of this section, you should be able to differentiate between the types of machine learning problems and recognize the appropriate type for any problem that you come across. We'll do a double click on the different types of machine learning problems. We'll start off with classification and look at the different techniques used to solve classification problems. With each category, we'll describe the basic approach to solve the problem and also some of the practical challenges involved. And we'll do this with all the categories of machine learning problems. At this point, you would have got a broad picture of the machine learning landscape, the types of problems, the different algorithms, and some of the challenges. It's now time to put this all to work. We'll spend time on specific machine learning problems and techniques such as natural language processing, sentiment analysis, ensemble learning, recommendations, and we'll implement the solutions to these in Python. For all of these, you'll need a basic knowledge of Python programming. We'll introduce the special libraries that you'll need as we go along into each of the problems. We'll create our own corpus of newspaper articles and apply classification and clustering algorithms on them. We'll build a complete project to connect to the Twitter API, fetch tweets for a specific search term, and find the general sentiment for that search term. We'll take one of the famous starter problems from competitive data science communities and solve it using decision trees. We'll then understand the challenges of overfitting and mitigate it using techniques such as ensemble learning. Personalized recommendations on Amazon, Netflix, and the like are some of the most commonly encountered applications of machine learning. We'll learn about the different categories of recommendation algorithms and implement them in Python. The newest frontier in machine learning is deep learning. This is a step in the quest to achieve artificial intelligence, and it's the technique used in cutting-edge technologies such as self-driving cars and the Google Brain project. We'll end our course by just getting a taste of this research area by solving one of the famous starter problems in computer vision. By the end of this course, you should be able to spot situations where machine learning can be used, identify the type of problem you're solving, pre-process and set up your data in the right way, implement the right machine learning algorithm in Python, and then evaluate your solution using techniques like cross-validation.